Hey everybody, I'm just going to talk through that example. 15x squared minus 11x minus 14. We'd like to put it in this form. First thing, I'm going to set up my chart. I know that a times c goes here. That's going to be 15 times minus 14 gives me minus 210. My b value, minus 11, is going to go here. I want to find numbers m and n such that when I multiply them together, they give me minus 210. And when I add them together, they give me minus 11. Okay, and if we were to actually go through the way of, rigorously solving this equation, we'd have to solve a quadratic equation. We're going to try to avoid that. We want to do this in our head. Try to find m and n such that when I multiply them together, I get minus 210. When I add them together, I get minus 11. Well, we think about it for a while, and we come to the conclusion that there's only two numbers that work. And it doesn't matter which one is which, but one is minus 21, the other is 10, right? Minus 21 times 10 gives me minus 210, and minus 21 plus 10 gives me minus 11. And you could switch them. It doesn't matter which one is m and which one is n. Okay, so my next step is I'm going to just rewrite the equation I was given. I'm going to say, okay, from my identity, I know I can rewrite it like this, where 1 over a is 15, multiplied by a times x, 15 times x, plus one of my values, and since it's a minus 21, I'm going to subtract 21. That quantity, open up a new set of parentheses, 15x, that's my a, 15x plus the other value that I found, 10, close that parenthesis. That's my expression. From there, I've got them separated. I just need to simplify it a little bit. I'd like to get rid of that 15 over there. So something I notice that's common to the 15x and the minus 21, both 15 and 21 are divisible by 3, right? So I can pull a 3 out, and that becomes 5x minus 7. If I distribute that 3 back in, I get 15x minus 21. All right, and then this term, well, I notice that it has a 5 common to the 15 and the 10. I can pull that 5 out, leaving me with a 3x plus 2. Well, now the 3 and the 5 that I've pulled out cancel with the 15 that was multiplied out front, and I'm left with only integers. If I'm putting it in this form, my little a is 5, little b is minus 7, right? There's a plus sign there, so this is a minus 7. C is 3, D is 2. I think in the problem in class, the answer anticipated that one of these would be negative, and so all of your constants would be positive in that case, because I think the form was replacing one of these positive signs with a negative sign. From here, it's easy to see what our roots are. It's what value x needs to be to make one of these equal to 0. So 5x minus 7 is 0 when x is equal to 7/5. 3x plus 2 is equal to 0 when x is equal to minus 2/3. So these are our roots. And they're easier to find when the equation is in, or when the function is in this form. Okay.